everyone, welcome back to our channel. In this video, we'll study about the reactions in solutions. Yes, we all know that in our chemistry, we have to deal with number of reactions and we have to deal with number of experiments in laboratory, right? Then how we do the reactions? Of course, we do the reactions by taking reactants, one or more reactants. But we can't do the reactions by taking any of the solid reactant. That reactant should be in its solution form, right? Then what do you mean by solution? Solution is nothing but a homogeneous mixture of solute and solvent. What is solution? Solution is homogeneous mixture of, it is a homogeneous mixture of solute and solvent. Okay. What do you mean by solute? Solute is the one which is in lesser amount, which is in small amount, which is dissolved in solvent. Solvent is the one which dissolves the solute and which is in large amount. Okay. For example, you can take sugar solution. In sugar solution, sugar is the solute and water is the solvent. And the combination of sugar and water becomes sugar solution. This is nothing but the solution. Okay. Like that, we have to take the reactants in their solution form. Right. Now we got to know that reactions should be carried out in their solution forms. But what is the amount of solute or what is the amount of component present in that solution? Means what is the concentration of that solution? These concentrations can be expressed in these four ways. These are the four different ways of expressing the concentration of the solute or the solutions. Okay. Those are mass percent, mole fraction, molarity and molality. We can use any one of these methods to express the concentration of solute or solution. Okay. We'll see these four one by one. First we'll start with mass percent. Okay. First one is mass percent. Okay. This can also be written as like this, mass and percent. It is also one of the way of representing the concentration of any of the element present in any of the solution or the component. Okay. Here what do you mean by mass percent? It tells about what is the mass percent of the element or the solute present in total amount of solution. For example, means first we'll see the formula, how to calculate the mass percent. Mass percent, that is equal to mass of solute divided by total mass of solution into 100. This is how we can calculate the mass percent. Here we have to take the mass of the solute, that is divided by, this is total mass of the solution. Not only we are taking the solvent here. Here it is the total mass of solution, that is multiplied to 100. Then we'll get the mass percentage. Or we can see one example. For example, you take any one solute. For example, you take sugar only. We have taken the 2 grams of sugar, that is dissolved in, solute is 2 grams, that is dissolved in 18 gram water. Now they are asking us the mass percent of sugar. So how to calculate this? Here mass of the solute, that is 2 divided by total mass of the solution they have given. So we should not take directly 18. This 18 should be added to the 2 because we have dissolved the 2 grams of sugar in 18 grams. So the total mass of solution becomes 18 grams water plus 2 gram sugar, that is multiplied to 100. Then we will get 2 by 20 into 100. It will become 10%. So this is the mass percent of the sugar present in the sugar solution, that is 10%. This is how we calculate the mass percent. Okay. We'll see next one, that is mole fraction. Second one is mole fraction. It is nothing but the ratio of number of moles of solute or the component present in total number of moles of solution. For example, you take A. A is the substance which is dissolved in B. So their number of moles are expressed like Na. This is the number of moles of A, and Nb. This is the number of moles of substance B. Okay. It is the ratio of number of moles of solute to the total number of moles of solution. Mole fraction, that is equal to number of moles of solute divided by total number of moles of solution. Okay, this is solution. For example, now they are asking calculate the mole fraction of this A substance. Then what we have to do, this is the number of moles of this solute. Here A is the solute and B is solvent, and that is divided by total number of moles of solution. In solution what we have A also and B also. So this must be solution. Number of moles of solution must be the addition of number of moles of A plus number of moles of B. This is the mole fraction of substance A. If they ask mole fraction of B, then you take number of moles of B, that is divided by number of moles of A plus number of moles of B. This is the total number of moles of solution. This is how we calculate the mole fraction. Okay. Now we'll see the next one, that is molarity, which is very important one. So the third one is molarity. Molarity is one of the widely used concentration representing method, which is very much used in any of the experiments and in laboratories, right? Molarity is represented by capital M. Then what do you mean by molarity? Molarity is defined as number of moles of solute present in 1 liter of solution. Here number of moles of solute present in or dissolved in 1 liter of solution. Here we are taking the solution, not the solvent. Okay, this you have to keep in mind, that we are using the solution here, not the solvent. That is, solute should be present in moles and the solution should be taken in liters. Okay, the unit of molarity is, here we have moles and here we have liter. So it is moles per liter. Unit of molarity is moles per liter. We'll take one example. You take 4 moles of NaOH dissolved in 1 liter water. Dissolved in 1 liter water. Then it will become number of moles of solute, that is 4 moles NaOH, which are dissolved in 4 moles NaOH, which is dissolved in 1 liter of water. So it will become, I'll write here, 4m. The molarity is 4m. Molarity of the NaOH becomes 4m. So like this is how we calculate the molarity. Means here it is the number of moles of solute dissolved in 1 liter of solution. Okay. Now we'll see the next one. The last one is molality. It is molality, that one is molarity. Okay. Molality is denoted by small m. Molarity is denoted by capital M. Okay. This is the difference. Here molarity. What do you mean by molality? Sorry. Molality. Molality is number of moles of solute present in 1 kg of solvent. Here we have taken the solvent. In molarity, what we have taken? We have taken solution. But here we have taken the solvent, that too in kgs. There it was in liters, right? So molality is nothing but the number of moles of solute dissolved in kg, 1 kg of solvent, right? Okay, we'll see the same example. You take 4 moles NaOH dissolved in 1 kg water. Okay, 4 moles in 1 kg. Then it will become 4 divided by 1, that is 4 m. Here it is denoted by small m. So the molality becomes 4 m. And the unit is moles per kg. Moles per kg, because here we have moles and here we have the unit kg, that becomes moles per kg. This is the unit, and that combinedly this moles per kg is written as m, small m. This is molality. It is molality. Now we'll see another example. Now you take 40 grams NaOH dissolved in 1 kg. 40 grams NaOH dissolved in 1 kg. Now what should be there in the numerator? The solute should be in moles. But in what they have given? They have given it is in grams. Now we have to convert this into moles. How to convert? Number of moles is equal to mass by molar mass. This we know. Okay. This is the mass what they have given. They have given 40 grams. And what is the molar mass of NaOH? That is also 40. So we'll get 1. This is 1 mole. Okay. Now we got it in moles. Now we'll just put that into its formula. 1 mole, we got 1 mole, that is dissolved in 1 kg. So we'll get 1 only. It will become 1 molar. So if we dissolve 40 grams NaOH in 1 kg water, that's molality becomes 1. Okay. This is how we convert the grams into moles and we do the calculations. These are the 4 different ways of expressing the concentration of any of the solvent or solutions in reactions. Okay, in reactions it is very much important to express the solution concentration of solutions and solvents. Without knowing their concentration, we cannot write any of the experiments. If we know the concentration, then we can also predict the reaction product. Okay, this is how we calculate the different concentrations by using the 4 different methods. I hope you got all these 4 methods of calculating the concentration of reactants and products. Okay, if you have any doubts, you can ask me in comment section. Have a nice day. Bye.